Question number 6. Show that f from close interval -1 to 1 to r defined by fx is equal to x upon x plus 2 is 1 1. To show that this is 1 1, and the criteria for 1 1 is that taking fx1 is equal to fx2, we must have only one and only one result, x1 is equal to x2. So for any two arbitrary element x1 and x2 from the domain close interval -1 to 1, we assume fx1 is equal to fx2. We have to write down here fx1, which is obtained by replacing x by x1 in the function. So if we replace here x by x1, we get x1 upon x1 plus 2, x1 upon x1 plus 2. And similarly, fx2 is x2 upon x2 plus 2. Now cross multiplying, we have x1 into x2 plus 2 is equal to x2 into x1 plus 2, or x1 into x2 plus 2x1 is equal to x1 into x2 plus 2x2. From left hand side and right hand side, x1, x2 are cancelled. We get 2x1 is equal to 2x2, and 2 is cancelled by 2. We get finally x1 is equal to x2. Since fx1 is equal to fx2 yields only one relation between x1 and x2, which is x1 is equal to x2, and this is the criteria of 1 1 function. Thus we may say that f is 1 1 function. Next, we need to find out the inverse of function. So let y is equal to fx. Y is equal to fx is given as x upon x plus 2. Transposing x plus 2 to the left hand side, we have y into x plus 2 is equal to x. Opening the bracket, y will multiply both of them. We have xy plus 2y is equal to x. Now transposing xy to right hand side, we have 2y is equal to x minus xy, or x minus xy is equal to 2y, or taking x common out of these two terms, we have x 1 minus y is equal to 2y. Transposing 1 minus y to right hand side, we get x is equal to 2y upon 1 minus y. Now in this step, we have to replace x by f inverse x and y by x. We get f inverse x is equal to 2x upon 1 minus x, where x is not equal to 1. So this is the required inverse of the given function. Now question number 7, consider f from R to R, and fx is given by 4x plus 3. We need to show that f is invertible. That is, we have to show that fx is a bijective function. So let us talk about injectivity first. Let x1, x2 belongs to R such that fx1 is equal to fx2 implies that 4x1 plus 3 is equal to 4x2 plus 3, or cancelling 3 from both sides, we are left with 4x1 is equal to 4x2, and here 4 is cancelled by 4, so we get x1 is equal to x2. So ultimately fx1 is equal to fx2 yields only one relation between x1 and x2, which is x1 is equal to s2. So the criteria for 1-1ness is satisfied. So we may say that f is 1-1 function. Now let us talk about trajectivity. For subjectivity, we need to find out range of the function. So let y is equal to fx or y is equal to 4x plus 3, because fx is equal to 4x plus 3. Now we need to find out the value of x in terms of an expression of y. So transposing 3 to left hand side, we have y minus 3 is equal to 4x. And now transposing 4 to left hand side, we get y minus 3 upon 4 is equal to x. So x is equal to y minus 3 upon 4. Since for every real value of y, x is defined, so range of the function is R. Codomain of the function is also R. So here a range of f is equal to codomain of f. Thus f is invertible because f is a bijective function. So f is bijective and thus invertible. Find the inverse of f. The second part of question number 7. So y is equal to fx, that is y is equal to 4x plus 3, and as we have x is equal to y minus 3 upon 4, here replacing x by f inverse x and y by x, we get x minus 3 by 4. So required inverse of the function is x minus 3 upon 4. Now in question number 8, f is defined as a function from all the non-negative real numbers to the interval, semi-closed interval 4 comma infinity. It is defined by fx is equal to x square plus 4. Show that f is invertible. First part of the question is we need to show that fx is invertible. So let us talk about injectivity first. Let x1 and x2 be the two arbitrary elements from the domain R positive, such that fx1 is equal to fx2. It implies that x1 square plus 1 is equal to x2 square plus 1. So 1 is cancelled from both sides. We have x1 square is equal to x2 square, or transposing x2 square to left hand side, we have x1 square minus x2 square is equal to 0. Applying the identity a square minus b square is equal to a plus b, a minus b, we may write x1 square minus x square as x1 plus x2, x1 minus x2 is equal to 0. It implies that either x1 plus x2 is equal to 0 or x1 minus x2 is equal to 0. Since x1 and x2 both belong to R positive, that is non-negative real numbers, and sum of two non-negative real numbers may not be 0, so this result is not valid, or we may say that this is an absurd result. And the second one is x1 minus x2 is equal to 0 is the only valid result. So from this we infer x1 is equal to x2 transposing x2 to right hand side. So finally, for the domain R positive, there is only one valid result, x1 is equal to x2, for the condition fx1 is equal to fx2. So f is 1-1 function. Now let us talk about surjectivity of the function. As we have done before, we need to find out range of the function. So let y is equal to fx. It implies that y is equal to x square plus 4, or x square is equal to y minus 4, or x is equal to under root y minus 4. Here x is defined for all y minus 4 is greater than or equal to 0, or y is greater than or equal to 4. So y is greater than or equal to 4 means from 4 to plus infinity, and that way there will be closed interval because there is equality with this greater than sign. So range of function is equal to closed interval 4 comma infinity. The codomain of the function is also the interval from closed interval 4 to infinity. So we may say that range of f is exactly equal to codomain of f. Thus, f is onto function as well. And since f is 1, 1 as well as onto, f is a bijective function. And since f is a bijective function, f is invertible. So we have shown that f is invertible, and now we have to show that f inverse of the function is given by under root y minus 4. So let y is equal to fx, or y is equal to x square plus 4, or x square is equal to y minus 4, or x is equal to under root y minus 4. Here replacing x by f inverse y, we write f inverse y is equal to under root y minus 4. So nobody should be confused about because before this sum we have replaced by x by f inverse x and fy by x to find f, the inverse of the function. But there are two provisions, that either we have to replace x by f inverse x and y by x, or we should replace x by f inverse y only, keeping y as it is. So here the second algorithm is used to find f inverse x according to the given question. So we needed to prove that f inverse y is equal to under root y minus 4. That's why we have replaced x by f inverse y over here. So inverse of the function is given by f inverse y is equal to under root y minus 4. Now the next term is ninth one. F is defined from r positive to semi-closed interval minus 5 to infinity, and fx is given by 9x square plus 6x minus 5. So in the first part we have to show that f is invertible. So first we have to show injectivity of the function, then surjectivity, and if the function is bijective then it is invertible. So let us discuss injectivity of the function first. For that we have to assume two arbitrary elements x1 and x2 from R positive such that fx1 is equal to fx2. It implies that fx1, that is 9x1 square plus 6x1 minus 5, is equal to fx2, that is 9x2 square plus 6x2 minus 5. Minus 5 from right hand side and left hand side are cancelled with each other. We get 9x1 square plus 6x1 is equal to 9x2 square plus 6x2. Transposing all the terms to left hand side, we have 9x1 square minus 9x2 square plus 6x1 minus 6x2 is equal to 0. Out of first two terms, 9 is common. So we have inside the bracket x1 square minus x2 square. And out of the next two terms, 6 is common, leaving x1 minus x2 in the bracket. Then 9 Here applying the identity a square minus b square, we may write it as x1 plus x2 into x1 minus x2 plus 6 x1 minus x2 is equal to 0. Taking 3x1 minus x2 common out of these two terms, so we have 3 x1 minus x2. Inside the bracket, we have thrice x1 plus x2 plus 2 is equal to 0, or 3x1 minus x2, 3x1 plus 3x2 plus 2 is equal to 0. Now proceeding from this step, transposing 3 to right hand side, we have x1 minus x2, 3x1 plus 3x2 plus 2 is equal to 0. So either x1 minus x2 is equal to 0, or 3x1 plus 3x2 plus 2 is equal to 0. Since x1 and x2 both belong to R positive, that is all the non-negative real numbers, and for any two non-negative real numbers, the expression 3x1 plus 3x2 plus 2 may not be equal to 0, because all these three terms are positive and the sum of three positive numbers may not be 0. So this is impossible result. We have only one valid condition, that is x1 minus x2 is equal to 0. From that we have x1 is equal to x2. So finally we may conclude that fx1 is equal to fx2 implies that x1 is equal to x2. Thus the criteria for one-oneness is satisfied, and we may conclude that f is one-one function. Now we have to show that it is surjective as well. For surjectivity, we need to find out a range of the function. Let y is equal to fx, that is equal to 9x square plus 6x minus 5. Or we may write it as 9x square plus 6x minus 5 minus y is equal to 0. We may write it as 9x square plus 6x minus common out of these two, we have 5 plus y, or y plus 5. So this is a quadratic equation in x where a, that is the coefficient of x square, is 9, b, that is coefficient of x, that is 6, and c, that is constant term, which is supposed to be minus y plus 5, in order to establish a relation between x and y. So using quadratic formula, x is equal to minus b plus minus under root b square minus 4ac upon 2a. We have x is equal to minus 6 plus minus under root b square, that is 36, minus 4a is 9, multiplied by c, that is minus y plus 5, divided by 2a, that is 18. That is equal to minus 6 plus minus under root 36. This is 4a, that is 4 into 9. So 36 minus and into minus plus 36. Inside the bracket we have y plus 5 divided by 18. Now proceeding from this step, x is equal to, since domain is non-negative real number, so this negative sign should be neglected, because if we consider this negative sign, this minus 6 and minus, this expression must be a negative number, which is not possible. So we may write it as minus 6 plus under root 36 plus 36 y plus 5 divided by 18, or minus 6 plus 36 can be taken out as common, so under root 36 becomes 6 outside, and under root 1 plus y plus 5 divided by 18. So taking 6 common out of it, we have inside minus 1 plus under root y plus 6 upon 18. So 6 will divide 18 3 times. So finally we have x is equal to under root y plus 6 minus 1 upon 3. Let it be equation number 2. Now since x is non-negative real numbers, under root y plus 6 minus 1 upon 3 must be greater than or equal to 0. So transposing 3 to right hand side, we may write it as under root y plus 6 minus 1 is greater than or equal to 0. Now proceeding from this step, under root y plus 6 is greater than or equal to 1. Or squaring both sides, we have y plus 6 is greater than or equal to 1. Or y is greater than or equal to. Transposing 6 to that side, it becomes minus 6. So 1 minus 6 becomes minus 5. So y is greater than or equal to minus 5 means y belongs to square bracket minus 5 to infinity. So this is the range of the function. Codomain of the function is also the same. So range of f is equal to minus 5 to infinity, which is also equal to codomain of the function. So since range of f is equal to codomain of f, function is onto as well. Thus we may conclude that since f is 1 1 as well as onto function, therefore f is bijective, and thus f is invertible. So we have proved that f is invertible. Now the second part, we need to find out the inverse of function. For finding inverse of the function, we may use equation number 2, because if we need to find out inverse of a function, first we need to write the function as x as a function of y, and then we have to replace x by f inverse x and y by x, or simply we may replace x by f inverse y. So replacing x by f inverse y in equation number 2. F inverse y is equal to under root y plus 6 minus 1 upon 3. Now the sum number 13, f is defined from R to R, and fx is given by 3 minus x cube whole raised to the power 1 upon 3. We need to find out f of x, that is defined as f of fx, and f of fx is obtained by replacing x by fx in the function fx. So if we replace here x by fx, on the right hand side we get 3 minus fx cube whole raised to the power 1 upon 3. So bracket 3 minus fx whole cube whole raised to the power 1 upon 3. Now in the next step, we have to substitute the value of fx, which is given as 3 minus x cube whole raised to the power 1 upon 3 over here. We have a square bracket 3 minus curly bracket 3 minus x cube whole raised to the power 1 upon 3 curly bracket close cube whole raised to the power 1 upon 3. Simplifying this, 3 minus, if we open this curly bracket, so these two powers will multiply each other. So if we multiply 1 upon 3 and 3, we get 1. So simply we have 3 minus x cube whole raised to the power 1 upon 3. So square bracket 3 minus 3 plus x cube whole raised to the power 1 upon 3. Positive 3 minus negative 3 are cancelled with each other, and we are left with x cube raised to the power 1 upon 3. Now, if we open up this bracket, we have x raised to the power 3 into 1 over 3. And simplifying this, we have simply x raised to the power 1, which is x. So, f of x is equal to x. So, option C is correct.